In this video segment, we'll be discussing the traversal and deletion operations of doubly linked list. First, let us discuss the traversal operation. This is the algorithm for traversing through the doubly linked list. Step 1, start. Step 2, set pointer is equal to head. If pointer is equal to null, then print doubly linked list is empty. Else, we have to move through each node and print the data part. While pointer not equal to null, then print the pointer data and pointer is equal to pointer next. So using this algorithm, you can traverse through the doubly linked list and print each element. This is an example. So this is a doubly linked list. This is head, and we can see previous and next links. Set pointer is equal to head. Traverse through all the nodes of the doubly linked list, and during the traversal, print the data part. So this is how traversing of a doubly linked list is done. Next, let us discuss the deletion operation in doubly linked list. The deletion can be done in 3 different positions. So first one is deleting a node from the beginning of a doubly linked list. So this is the algorithm. Step 1, start. Step 2, if head is equal to null, then we can simply print as doubly linked list is empty. Else, we have to delete the first node of the doubly linked list. So set pointer is equal to head. So pointer will be here. If head next is equal to null, then head is equal to null. So this is the case when the doubly linked list contains only one node. In that case, you can simply assign head is equal to null. And in the else case, there are more than one node in the doubly linked list. So you can point head to the next node, like assigning head is equal to head next. So head will be pointing to this node, and head previous is equal to null. And this will be the node pointed to by PTR. You can simply delete the node or deallocate memory using the free function. So this is the algorithm for deleting a node from the beginning of a doubly linked list. Next is deleting a node from the end of the doubly linked list. This is the algorithm. Step 1, start. Step 2, we are checking whether the doubly linked list is empty or not. If head is equal to null, then print the message doubly linked list is empty. Else, we have to traverse through the doubly linked list till we reach the last node, and we have to delete the last node. So here set pointer is equal to head. If head next is equal to null, then head is equal to null. This is done when the doubly linked list contains only one node. In that case, you can simply assign head is equal to null, and deletion can be done. And in the else case, traverse through the doubly linked list until we reach the last node. While pointer next not equal to null, we should do pointer is equal to pointer next. Now simply assign pointer previous next is equal to null. And when we are executing this statement, automatically the last node will be removed from the doubly linked list. Afterwards, simply delete the node pointed by PTR using the free function. So this is the algorithm for deleting an element from the end of the doubly linked list. Let's look at an example. So here this is the doubly linked list. We have to delete a node from the end of the doubly linked list. So here we are starting a pointer from head, and we are traversing through the doubly linked list until we reach the last node in the list. So pointer next is not equal to null is checked, and we are moving to the next node using this statement. So pointer is moved until it reaches the last node. Now what is done? Pointer previous next is equal to null. So pointer previous is this node. this node's next part is equal to null. This part is null. Now there is no link between this node and this last node, and thus this last node is deleted from the doubly linked list. So this is how the doubly linked list looks like after deleting the last node. Next is the algorithm to delete a node from the specified position of a doubly linked list. This is a doubly linked list. In this particular algorithm, we will be deleting a node from the specified position of the list. For example, if position is equal to 1, we have to delete this node. If position is equal to 2, this node. Position is equal to 3, this node, and so on. So this algorithm is to delete a node from a specified position of a doubly linked list. So this is the algorithm. Step 1, start. Step 2, if head is equal to null, then print doubly linked list is empty. That is, if head is equal to null, there will be no doubly linked list and we cannot delete anything. So you can just print a statement like this. And in the else case, you are checking whether the position value given is less than or equal to 0. If position value is less than or equal to 0, then you cannot delete because our first node has position is equal to 1. So you can print a message like position must be positive. Else case, you can start a pointer ptr is equal to head. If the user has given position is equal to 1, then the first node is to be deleted. So you have to check whether head next is equal to null. This is checked to see whether this is the only node, there is only one node in the doubly linked list or not. In that case, you can simply assign head is equal to null. Else case, you can assign head is equal to head next and head previous is equal to null. Head is equal to head next means head is moved to the next node and its previous part is made null, and thus the first node in the doubly linked list is deleted. And consider the next case if the position was not is equal to 1. In that case, set pointer is equal to head and initialize a count variable to 1. Now you have to traverse through the doubly linked list and reach the node that is to be deleted. So while count is less than pos and pointer not equal to null, then pointer is equal to pointer next. And in each iteration you are incrementing the count variable. Now even after searching, even after traversing through the whole doubly linked list, if the pointer value was null, then we can say that the position value entered by the user was out of range of the doubly linked list. That is, if doubly linked list had only 3 nodes and the user asked to delete the 4th node, then there is no 4th node in the doubly linked list. In that case, deletion is not possible. So if pointer is equal to null, then you can print doubly linked list is out of range. And in the else case, if pointer next equals null, that is, if the node to be deleted is the last node, then pointer previous next is equal to null. That is, to delete the last node, you can use this statement as we discussed in the previous algorithm. Else. In this else case, we are considering the deletion of node in between the first and last nodes. If any of the nodes in between is to be deleted, you can use these two statements. So pointer is pointing to the node to be deleted. So pointer's previous node's next part is changed to pointer next, and pointer's next node's previous part is changed to pointer previous. So these are the statements used for deleting a node which is in between the first and last nodes. And afterwards you have to deallocate the memory pointed to by ptr using the free function. So this is the algorithm for deleting a node which is in the specified position in the doubly linked list. So let us see the example. So this is a doubly linked list. Assume that the user gave position is equal to 1. This means you have to delete the node from the first position. So here head is pointing to this first position. So you can simply assign pointer is equal to head. and you can move the head from this node to this node by changing head is equal to head next. So head will be moving to this position, and you have to remove the address of this node from the previous part. So you can simply write head previous equals null. So this node will be removed from the doubly linked list. Now let us discuss the next case, that is we have to delete a node from position is equal to 4. So here this is the position equal to 1, this is 2, this is 3 and this is 4. So for deleting this particular node, we have to assign a pointer and you have to traverse the pointer till we reach this node, and then you can delete this particular node. And for that, set pointer is equal to head, and you can start a counter, count is equal to 1, so that you can stop when we reach the position is equal to 4, and for that purpose this variable is used. So traverse through the doubly linked list until the PTR variable or pointer reaches the node to be deleted. Now check whether pointer is equal to null. If pointer is equal to null, print doubly linked list is out of range. This happens when the user inputs a value which is more than the number of nodes in the doubly linked list. So here we have only 4 nodes in the doubly linked list. If the user had input a value 6 or 7, we cannot delete the node at the 6th or 7th position. So in that case, this print statement will be executed. Now after this while statement, we have the pointer has reached here. Now we have to perform the deletion operation. So you can use the same logic we used to delete a node from the end of the doubly linked list. So if pointer next is equal to null, yes, pointer next part is equal to null. This means we are deleting the last node from the doubly linked list. So we should assign pointer previous. This is pointer's previous node. Its next part is made null. So here we'll be having a null value, and thus this node will be deleted from the doubly linked list. So this is the doubly linked list after deleting a node from position 4. Now let us discuss the next case, deleting a node from the specified position of a doubly linked list when POI is equal to 3 or position is equal to 3. So here this is position equal to 1, 2, 3. So you have to delete this particular node. And for that, you should start a pointer variable PTR. Change the pointer variable until we reach the node to be deleted. So pointer reaches here. Now you have to change this particular value and this particular value. So pointer's previous node's next value is equal to pointer next, and pointer's next node's previous value equals pointer previous. By assigning these two values, you can simply delete the node from the doubly linked list. So this is how the deletion of a node from a specified position of a doubly linked list is done. In this video segment, we have discussed the traversal and deletion operations of a doubly linked list. Thank you.